Lesson 8.6. Lesson 8.6, if you notice, is entitled Any Way You Slice It. So what I want you to do is I want you to go ahead and look up here on the board. I have on the left side, these are sectors. On the right side, I have these are not sectors. So based on looking at what is and what isn't, I want you to go ahead and determine what a sector is. I'm going to give you roughly about 15 to 30 seconds in your groups. Go. All right. So what do we have? What do you guys have for a sector?
Something that could be divided into equal parts from the center of the circle to the outside.
Okay. So equal parts. What do you mean equal parts?
Like 2 radii.
Okay. So basically, when you say equal parts, you're referring to these.
Yes.
Okay. What did you guys have?
Something that goes from the center of the circle, the 2 lines that divides it into sections or functions.
Okay. So something that goes from the center of the circle. That's important. It has to go through the center in order for it to be a sector. Now what we're going to do when all is said and done, you've got some other ones we're going to look at as well. We're going to go through the definitions I have, and based on your definition, if you like your definition better than mine, that's fine. Okay, but that's what a sector is. We have these are sectors, these are not sectors. Now what we're going to do is we're going to look at a segment. These are segments, these are not segments. So now I'm going to give you once again roughly 15 to 30 seconds. I want you to look on the board, tell me, okay, after you discuss with your group, what a segment of a circle is. All right, girls, I'll start with you first. What do you think a segment of a circle is?
Something that goes from one side of the circle to the other side without going through the center.
Okay, what about you guys?
A line that measures 2 points in the circle.
Okay, real quick, let's think about definitions. Do we remember what this is called?
Chord.
Ah, chord.
Oh, that's cool.
So I wonder if that ties into the definition at all. All right, let's look at this. Annuluses. Okay, sorry, I had to pronounce it again. Okay, so these are annuluses. These are not annuluses. So this is a new word. I bet you've never heard of the word annulus before. So what I want you to do is come up with the fact an annulus is. Now let's try and utilize some of our previous knowledge a little bit with this. Okay, we'll start with the boys. What is it?
The region between each smaller circle and
The
the
region.
concentric circles.
There we go, concentric circles. I wonder if that'll have to do somewhere. All right, girls, what'd you have?
Circle within a circle that has the same center.
Okay, circle within a circle has the same center. All right, so let's see what an annulus is. So here are the 3 definitions I have. Now, like I said, if you like your definition, fine. That's great. Okay, this is a formal definition. A sector of a circle is the region between 2 radii and an arc of the circle. You guys were really close. You had the 2 radii. Okay, the only difference is you didn't have the arc. Okay, but once again, if your definition makes better sense, great. The next one, a segment of a circle is the region between a chord and an arc of the circle. The region between a chord and an arc of the circle. So notice how we're really tying in your prior knowledge. We're using the definition of an arc. We're using the definition of a chord. We're using the definition of a radii. Okay? For an annulus, that is the region between 2 concentric circles. 2 concentric circles. That's an annulus. So when you think about an annulus, you can think about a bullseye. So if you're taking archery in PE class, you could say, hey, that's an annulus right there. Okay. And everybody would probably look at you and say, what? All right, so anyway, that's an annulus. So those are some new definitions that we've got. All right, so now what we're going to do is we're going to talk about the area, how we find the area of certain things, specifically of sectors. Okay, so let's go ahead and look at this next slide. Okay. All right, so the area of a sector. This is taken from your book. You're going to notice that the area of a sector, and this is the important thing that you need to get, is the one at the very bottom. Okay, the area of the sector. Basically, A over 360, that's the angle. A refers to the angle. So another place you might see that angle written is right here. And that should make sense because A over 360 is what fraction of the circle you're dealing with. So if A was 90, you would have 90 over 360, right? What does 90 over 360 reduce down to? 1/4. Well, you know that 90 degrees is 1/4 of a pizza. Okay? If you had like 180 over 360, that is 1/2. So that's like half of a pizza. So you're just taking half times your area. So that A over 360, that's basically what fraction of the circle you're dealing with. And you're going to take that times the area of a circle. All right, so now what we're going to do is how you find the area of a segment. Now this one's a doozy. Okay? So first of all, how you find the area of a segment is you're taking the area of a sector first. And then you're subtracting off that triangle. Okay? The area of the sector first minus the area of that triangle. That will leave you with the area of a segment. Okay? So the area of the sector, so we've got the sector here, minus the area of the triangle. Okay? And that will give you the area of the segment. And then last but not least, the area of an annulus. Notice what that is, pi r squared, where r is the big radius, minus pi r squared of the little radius. And that's the area of an annulus. Okay, and that one's an easier one. Okay, so pi big R squared minus pi little r squared is the area of what? A what? Annulus, okay. So let's go ahead. Oops, I think I skipped one. Yep, I did. Find the area of the shaded sector. Find the area of the shaded sector. So what we're going to do is all I'm going to do is take the angle, in this case 45 degrees. I'm going to divide it by 360. I'm going to take that times pi times 20 squared. That's all you're going to do.
Can this be in terms of pi, so?
Yeah, depending on what your book asks or what the instructions are, you can either answer all decimals or you can answer in terms of pi. 45 divided by 360 is 1 what?
1/8.
That's 1/8. So I end up having 1/8 times pi times 400. So if you were to leave that in terms of pi, your area would be 50 pi centimeters squared. If they wanted you to go ahead and multiply that out, you would take 50 times pi. And 50 times pi is what? 0.08. Now, if you're using one of my calculators and you just get 50 pi and you can't get a decimal equivalent, hit the double arrow right above the enter button, and that will convert it to a decimal. All right, so let's look at another one. Find the area of the shaded segment. Ooh. Okay, what was the area formula? It was A over 360 times pi r squared, because this is the area of the sector, minus the area of the triangle, 1/2 BH. Okay. What's the angle I'm going to use? 90. So really what you could do is you could put 1/4 times pi times 6 squared minus, oh boy, here's my base, here's my height, so 1/2 of 6 times 6, which is 18, as you've already said. So 90 over 360 is 1/4 times pi times 6 squared, which is 36, minus 18. Now, if the question asked you to leave this in terms of pi, okay, this will reduce to 9 pi minus 18. And if they asked you to leave it in terms of pi, that's your answer. You stop right there.
What's 6 times 6 minus half
Oh, never mind. Never mind.
Okay, so if they asked you to leave it in terms of pi, this would be your answer.
So you can't do
Okay, you can't combine the pi and the 18. You can't do it. So you just leave it as it is. All right, we have one more. What do you think we're going to find the area of? Annulus, good call. But not. Okay. The shaded area is 14 pi centimeters squared, and the radius is 6 centimeters. Find x. So that's an area of a sector, right? So the area of a sector, we know by definition, is A over 360 times pi r squared. So let's fill in what we know. We know the area of a sector is 14 pi. The angle I'm trying to find, so I'm going to leave that as A over 360. And I know the radius is 6. So now in looking at that, all right, we have one variable, which is A. So here I get 14 pi equals A over 360. Here I get times pi times 36. All right, so let's cancel out. I get 1, 10. So I end up with 14 pi equals A times pi divided by 10. Oops, for some reason that didn't. Right. Let's try it again. There we go. What happens to your pi's? They cancel? How do you solve for A? Multiply by 10. So what does A equal? A equals 140 degrees. Okay, think you can handle that? All right, let's see how we do. You have 1 through 14, page 455 through 456. Now, we'll probably have a short quiz tomorrow. Okay, so.
Would you make it